In the last video, I demonstrated the assembly and operation of this mini bottom-fed crossbow magazine. So, you push the riser down, it locks into place, allowing you to load the bolts. Now, these are 3D printed bolts, tipped with nails, and then this part back here is hollow. So that gives it the perfect center of gravity. This fletching is printed separately, and then this shaft is printed like this on the print bed. So if you're looking down at the print bed, you would see it like this. There's just a big slit here, and then this little cutout here, this is a feature I like to call selectable knock. So yeah, this feature is called a selectable knock. I don't know if something like this already exists or not, but I came up with it the other day. This is actually really awesome because it's like better than a traditional serving, and it also acts as an arrow clip. So usually when a crossbow pulls a drawstring, it's got like this like hooked trigger with like two claws, and then once it's loaded, the bolt is supposed to be like butted up against the rope and then held in place with like an arrow clip. But with a selectable knock, you have a latch, just one claw that comes up, it goes over the string, selects the bolt, and then it pulls the string with the bolt. And the great thing about that is when it's locked and loaded, this will never unclip. It's like, unless you pull the trigger, this isn't going anywhere. I first used this design on this little mini pistol, so I'll just load a shot. See, like, it's got a latch right here. There, now it's latched. So the bolt is held in place. It's snugged as tightly up against the rope as possible, and it's not going anywhere. Unless I pull the trigger, it's never gonna fall out. But anyways, I digress. So, load this up. So this is the magazine spring, or the riser mechanism, I should say. The way it works is you have gear teeth running up one side of the magazine, and so this little riser just runs up and down. And it's the perfect kind of spring for a crossbow magazine, because with the gear wheels, it keeps it perfectly true. It keeps the bolts perfectly square with the box. And then also it utilizes this horizontal storage space we have by using a torsion coil. And I could have actually gotten a lot more, like a better spring rate out of this if I would have just made this one single coil going all the way across, which is what I'm going to be doing on my next design. Another cool thing about torsion coils is you can make the revelations paper thin so long as it's constrained on an axle and, like, you know, constrained inside of something so it can't go all over the place. That's one way you can make it a lot longer if you have limited space. Here's a previous design that's pretty groovy looking. I didn't end up going through with, but same concept, only this time it uses torsion spirals and gearbox. So the spirals don't move very much at all, but they're geared up, so that gets converted into speed and distance, which improves the spring rate and makes it behave more like a magazine spring. And when you're dealing with 3D printed springs, generally speaking, like 3D printing things flat or two-dimensional or like as one single pane is usually the way to go. So that's why torsion springs tend to outshine all the other springs that you can 3D print. I also like torsion coils too, because although they are a slight bit more brittle, they're also a bit more powerful. This is the mechanism that locks the riser in place to make loading more convenient. Alright, you can see it's just a two-dimensional spring concept. When you push that, it releases. basically the way this was supposed to work is this comes up and then you can like latch a bolt over there, and then it's supposed to go down and then you fire the bolt. But that actually ended up not playing out in reality so well, so kind of gave up on that. But the rest of this design is really great, so I'll just go over that. So like, if I can, I try to make all of my prints 100% 3D printable, and I like to use joinery for assembly and disassembly because it's a good semi-permanent solution and it's super fast. Whenever I'm designing magazines or like any kind of 3D printable shooty related thing, you want your internal mechanisms to be in the box. You want to print them inside up so you have a nice finish on the inside, so you have good internal mechanisms. And then once you have that done, then you print exterior mechanisms to cover all of that. And so the way I stick my halves together, one of my favorite go-tos is to run a dovetail down the seam, and then you just use a dovetail channel to lock it together. I also like to use filament right off the spool as dowels. If you use dowels in between the pieces and use joinery to close up the seams, it won't like wiggle around and feel cheap. So it became apparent that I was going to need to have a magazine that's like the Interceptor, where there's no obstructions and a bolt just magically floats above the top of the magazine. A long time ago I did attempt to make a magazine like the Interceptor, but as you can see, like 3D printed parts are just too flexible for a robust mechanism like this. So as far as I know, I think the Interceptor magazine is made out of metal. So here's some failed parts from the new prototype, but you can see the difference in scale. This seriously powerful corrosion right here. This will be the platform, and those will just get pushed up into the screws. To show an example, the way it connects is the end will get folded up, and then you feed the string through, and then you singe the end so it makes a big bulge end, and then it won't pull through. And because this is printed flat, this is actually very strong. For this prototype, decided to go with these cheap Amazon bolts. They're super cheap and they seem really high quality, like the best cheap bolt you can find. Like, look at that FOC. And I love that this is all just one material. I don't know how they made the end lighter. They must have made it hollow like I do on mine. But yeah, this is just a well engineered and cheap bolt. So I'm going to make the new magazine with these. And this is the mechanism I came up with. And it's genius. This would make Archimedes proud. Essentially what it does is it screws the bolt up into place using these big worm screws. It's all slide action. And so it's all torque. It's like, this is about 50 millimeters of distance, and the bolt is only lifting up like 6 millimeters or so. And then the gears that these screws are connected to are smaller diameter, so the actual helical length that these screws are turning is even longer than 50 millimeters, so it's probably over like a 10 to 1 gear ratio. Let's get a closer look at that. See, and there's other bolts there too. Basically all that needs to happen is the bolts need to be spring loaded up to the screws, and then the slide action takes care of the rest. And I already have a perfect spring system for that. So basically all I need to do is combine this, which I call thread gate, with this, which I call torsion drive. Combine thread gate, torsion drive, and then I should have the ultimate crossbow magazine, which is the essential ingredient to making the ultimate repeating crossbow. I also added letters to the worm screws, so like when it's in the locked and loaded position, the letters should just be like perfectly upright. So yeah, anyways, here's the model, and this is called Pandora X. Pandora, because you know Pandora's box, open it, fuck around, find out, that sort of thing. And then X, because cool crossbow kids always name stuff with X at the end, and it should. And then I made sure it holds 10 because X is also a Roman numeral for 10. So like, because I wanted to call it Pandora X, that prompted me to make sure it holds 10. Because I just figured if it has X in the name and it can't hold 10, that would seem like a rip-off. And it's basically the same kind of deal as the other one. You have the torsion drive riser, and then you have thread gate at the top. And this is the torsion coil. So instead of having two little flimsy ones, it's just one big torsion coil. And I tried adding some taper on the ends so that the ends are less susceptible to snapping off when it undergoes a lot of deformation. This is a sled, and what this does is it protects the string. It gives you a rigid body to latch to, and it protects the strings. No draw assists or mechanisms making contact with the string, just rigid body to rigid body contact, which is how it should be. I love how this mechanism is just all torque. Like, the helix is just the ultimate expression of torque. It's both the immovable object and the unstoppable force. If it wants to go through something, it goes through. If it doesn't want to move, good luck moving it. If it wants to push a bolt up to the top of a magazine, that bolt is going to go to the top of the magazine. So my goal with this is to hopefully get it working really well, finish it, upload it to Coles, sell it, and then hopefully makers will do something cool with it. And then I'm also going to design a repeating crossbow to go to it.